the opponent also asked about the inflation process. And there is no physical explanation of the parameters in the function, and we believe that she did not explain that, especially the A for the curve that she used, and we believe that is a parameter that should be measured, and it is dependent of the individual parameters of the balloon she's using. And for the experiments, I'll just talk about the weak points due to time limits, and the inflation is really quick and doesn't give the explanation fitting parameters, as well as the initial radius measurement is not precise and accurate, as she described in the Q&A session. And for discussion parts, the opposition question about the linear assumption for the upwards trends in the right part of the graph, and the opponent, we got that because of the accent thing. She said it was all right, but we agree with the opponent because there is actually a curve and the thing doesn't really work. And for the opponent also asked about the fitting parameters, and we believe that reporters talked about the polynomial correction, and we believe that this fitting parameters should be measured for individual balloons. And last one, missing. And for the missing parts, we actually believe that there are some physics missing behind. There are some physics missing behind all of this, especially regarding the parameters. Whatever. About the graph, the measurements, because she said she used the first balloon, and we think that that links to the question about the entire validity of her phase diagram because of the entire measurement or the fitting thing or the uniformity assumption.
Thank you. And the reporter has concluding remarks.
Okay. So I would like to clarify what's the method of fitting this curve. I had a small English problems. So it's a method of the least squares to fit this curves. Also, I would like to say that I checked the uniformity of my balloons. With this experiment, you can see that the deviation is quite small looking on this pressure curve. So I assume that these balloons are equal. Additionally, I would like to talk about the temperature. Both the reviewer and the opponent mentioned that it's an essential parameter. I would like to emphasize that when I pumped the balloons, I waited for the 30 seconds for them to be in the same temperature, and then the direction of the flow do not depend on there's the same temperature, so it is determined by my theory. Additionally, we are not talking about the temperature in Celsius degrees, so it changed from 20 degrees to 23 degrees in Kelvin scale, so from 300 to 303, so it's a very small change. And I would like to skip to the last slide. I would like to emphasize that we fully answered the task, and with our theory, we could predict it where the air will flow from the smaller balloon to the bigger, or from the bigger to the smaller. Also, there was a question about the inflation curve. Okay. So, I have here an inflation curve. I pump first balloon, it is here. I pump the second balloon, it is here. The pressure in this balloon is bigger than the pressure in this balloon, so the direction of the flow is fully determined by this curve. Thank you.
Thank you. And we move on to questions from the jury, and again, keep them short. And Kent.
To the reporter, can I just ask, you just mentioned that you waited 30 seconds before you pumped the balloon up, waited 30 seconds and then deflated, let them flow one way or the other. Does your pressure-volume relationship vary over time? Does the graph of pressure and volume, does that change if you just leave a balloon inflated?
Okay, so you are talking about the wearing out of the balloon?
Just with one inflation.
Okay, so if I once inflated, it's worn out.
Okay.
So
Okay, we'll move on. Catherine?
To the reporter, you mentioned that you deliberately used an inflation curve for the phase diagram rather than deflation. Can you explain why?
So I taken the inflation curve because the initial pressures of these two balloons is defined by the inflation curve. The lines on which these balloons will go depend on the deflation. However, we were asked about the direction of the flow.
Okay, thank you. Felicia?
Could you please take up slide number 20? So you have 4 numerical values here for A, alpha, B, and lambda. Did you change these for all of your experiments, or were they kept the same? So were they fitted or not?
Okay, so to determine this phase diagram, they were constant.
So they're the same for all experiments?
Because I taken the same balloons.
Okay, thank you.
Okay, thank you. Martin?
So am I correct that you are only interested in how the flow starts? Like which balloon, whether it goes from left to right or right to left, and you are not interested into the final state, so whether they equalize or the flow stops after a very short time, something like that?
Okay, so I wanted to fully answer the task. However, yes, that is an interesting point that there won't they won't have the equal pressure because there is a hysteresis in the system. Okay, so as you can see,
brief answer, please.
Depending on to which point we inflate our balloon, it will go on different curve.
So did you investigate the final state of the balloons?
From mine experiments, I can have the end volume of the balloons. However, it's hard to show it on a graph.
Okay, it's fine. Andrew?
Yes, I have a question to opponent. You said that if the rubber is very stretched, then the Gaussian model is no longer valid because the number of states is exhausted.
Yes.
Do you think if we add the correction to the Gaussian model, we can recover the stiffening at big elongation of the balloon?
I believe when we add the correction, it will fit with experiment results, but we do not have a lot of physical insights because the problem in the Gaussian model is that it does not take into account how the inherent geometry is limited, and we cannot have a rubber being stretched to infinitely long.
Okay, thank you.
Okay, thank you.
I got a question to the opponent as well. You mentioned that the process might not be isothermal.
Yes.
If so, could you give a correction, like a theoretical correction that should have been made to the problem?
I think the deviation might be about 10%. So regarding the correction, perhaps there should be a temperature dependence term in the overall motion of the balloon.
Okay, thank you. Ilya?
To the report on your phase map, we see that the experimental data points, they fall into several regions, and some regions are full of data points and some regions are empty. Why is that so?
Okay, so it's because in case of higher extensions, it is harder to pump the balloons, and then they just are ripped. So that's why.
Okay. Any further questions? Okay, follow up.
To the reviewer, quickly, you asked about, or mentioned in your review, that it would have been better to experimentally measure the fitting coefficients. Can you offer a quick way, how would you have done that?
So you're talking about how to experimentally measure the fitting coefficients, right? Okay. Because, like, can I refer to our work? Like,
Just
okay.
You've got 5 seconds to answer the
There is
question.
a uniaxial force, like, for the stretch of the balloon, and then you measure the uniaxial force for the rubber band, and then you get that.
Okay, thank you. We need to move on straight away, so do sit down while jury compile their marks. And again, please do write them down so I can see them. Okay, our jurors have compiled their marks, and so we move on to showing our marks. First of all, for the reporter team. Can you hold up your marks for the reporter team? And we start with 9, 6, 7, 5, 6, 8, 7, 6, 6, 6, and 8. And straight on to the mark for the opponent team. Holding up for opponents, we have 7, 7, 8, 7, 6, 6, 7, 7, 7, 7, 8. Thank you. And finally, the marks for our reviewer, holding up. Okay, 5, 6, 6, 5, 6, 7, 6, 6, 7, 6, 7. Okay, for our reporter, we have a definite variation in mark. We will start with Andre, a mark of 9.
Yes, so I gave you a 9 because I really like clear thermodynamic approach. I'm very easily impressed with StatMech usually, and there is not much of it in IYPT, and this is a very good argument. I think you had very good clear argument structure. I like the phase diagram, so I added you a point for reporter because it's a very good visual aid to explain when do we inflate back and forth. So I give +3 for physics, +1 for reporter. I think a well-put argument, good response for questions in the parts that were not so essential. So I think that the fact that balloons are not completely equal will not change your phase diagram too much, just a little bit on the boundaries between the two states. I think you appropriately answered that, so have no complaints. Thank you.
Okay, thank you. And Felicia?
I added you +1 for physics, because you obviously seem to know what physics you had. Unfortunately, I feel that this is physics you could find in a paper anywhere and just put it into your presentation. You understand it, but it's not new. And then I deducted you 1 point for reporter role because I felt that there wasn't enough experiments. I'm an experimentalist, and I feel like to fully understand this problem, you need to investigate more parameters, or like maybe different balloons, or to fully see what's happening.
Okay, thank you. If we move on to our opponent, we have 2 8s and 2 6s as the extreme, which not quite as extreme as the reporter. Do we have someone who'd like to address the 8 that they have given? Someone who's given an 8 for the opponent? Say, John?
Yeah, I would just say that I think it's a very important aspect that the opponent does lead the discussion and tries to bring out as much of the physics of the problem as can be done in the time available. And I think he did just that. He raised his own opinions without going into his own research, and also gave an effective critique of the report, I thought. So I thought it was a good opposition.
Okay, thank you. Valentin, do you want to add to that?
No, maybe I can add that I like the discussion, but it is below. Because, for example, you talk about isothermal process, but you don't argue about it. And nobody talk about it also. Neither reporter, neither reviewer.
Okay. Moving on to review, we have a 5. Anja, please.
Yes. I'll have to note I have not the only 5. There is another 5 also.
Yes, I know.
Felicia. Okay. Anyway, so for review, I gave you +1 for the physics and -0.5 for each of presentation and review role. So for physics, I think you asked a couple relevant questions about inflation, deflation, about the uniformity of the balloons, about how they measured the initial volume. So I think this is relevant physics, but there was this problem that you fumbled in the end with the explanation. You had the slide with the missing points in the report, which was, I think, just empty. So you didn't have a clear suggestion. And you just rushed through the review of what was happening, especially the slide about experiment. There was a concern in the jury about how much experiment was done, and I think you didn't do a good enough job of telling us how much experiment was done. And I usually think that giving in review a separate slide about the quality of presentation, especially if it's very generic, it's not really worth it. Unless you mention very specific visual aids, like the phase diagram. Thank you.
Okay, okay, good, clear. 5 also?
I felt that it was a standard review. It's what I would expect. There was some good physics point brought up. There was some that I felt you missed, and there wasn't anything exceptional. So I didn't add any points. I didn't subtract any points. So that's why I ended up with a 5.
Okay, thank you. And if we go to the other end, we have 3 people giving a 7. Ilya, would you like to comment on your 7?
Okay, so I think that your review was a reasonably good review, and I agree with the people who put you slightly lower grades that that you covered many points, but in particular you were a little bit generic and you were a little bit inspecific, and therefore I could not higher on my scale. But still, I think that your review was consistent. The points about the theory and experiments of the report and interpretation of the debate between the reporter and the opponent was covered quite well from the physical point of view, so I added you 1 point for physics. And also I think that your presentation was quite convincing. So again, on my scale, I could add you 1 point for the presentation. I could not do anything for your role, in particular for the reasons mentioned by Felicia and by Andrei. But still, I think that 7 is a consistent grade on my scale.
Okay, thank you. I don't